our oxygen-18 isotope record from the stalagmites is suggesting that the Little Ice Age had more enhanced tropical cyclone activity, or cyclones making landfall along this part of the North Queensland coast, than the medieval warm period. Now we've only got the last couple of hundred years of the medieval warm period, but we've got all of the Little Ice Age. And so
that's in the cave deposit.
Yeah, the cave deposit. And so it shows many more big cyclones coming through, making landfall. That doesn't mean that there were any more being generated out in the ocean.
Because they may not have reached the shore.
That's right. There may have been conditions that made them track more this way and make landfall. So that's kind of what we think may be going on. We actually had conditions that caused the cyclones to track more towards our coast here, and therefore have more impact on the coast than during the medieval warm period. So it may not be that it's about the number of cyclones developed in the ocean basin, but how many cyclones actually made landfall.
Make it to land. So you've got fewer in the medieval warm period, more in the Little Ice Age, and that contrasts quite a lot with what we see in Europe with coastal flooding events, whereby we have the opposite. We have more in the medieval warm period and less in the Little Ice Age, flooding the North Sea basins and so on.
That's right.
So it's quite interesting that it might be opposite.
It is. But we still don't have a good handle on the Little Ice Age in the Southern Hemisphere. Particularly in Australia. I mean, it's very hard to track that. Because we didn't have any glaciers or anything like that.
Absolutely.
So, it's still not positively identified here, and people are still really trying to search it and understand what it may have meant here, if anything at all.
That's it. Because in Europe, of course, the River Thames froze up.
That's right.
And we had frost fairs and things like that.
But,
so it's really obvious.
But of course, Australia wasn't settled really until the very, very end of the Little Ice Age, by Europeans that is. So we don't have any written records of anything.
Just on the cave deposits, you've been looking at the oxygen isotopes in the different layers laid down of calcite in the limestone regions. So what is it about the oxygen isotopes that you can differentiate between it being normal rainfall and cyclones?
Tropical cyclone rain has a very, very low level of oxygen-18 in it, compared to normal monsoonal rain and thunderstorm rain. We know this because studies have been done by chemists on the isotopic composition of different rains, and they've found this with hurricanes and tropical cyclones. So now what we've tried to do is see if we can get a long-term record that would be registering this tropical cyclone rain. And we have been able to find that.
Good.
So we're quite pleased about that.
So it's a very clear signal.
Very clear signal.
Fantastic.
Particularly when we match it up against our Bureau of Meteorology's.
What, within the last 100 years or so?
Since 1906 to 2004 we were able to match up things very, very closely.
Fantastic. So a physical proxy in the landscape matching up with instrumental records.
That's right.
Great.
That's right.
Brilliant. Very exciting.